In this video, I'm going to demonstrate the use of two built-in commands in Excel. One is for calculating the median of a set of data, and the other is for calculating the mean or the average of a set of data. And while we're doing this, I'm also going to show you an important principle about sensitivity to outliers of those two measures of center, the mean and the median. So here I've got in Excel two variables with no particular name. I just called them XXX and YYY. And our five values for the variable XXX are the even numbers 2, 4, 6, 8, 10, scattered, not in order. And my second variable called YYY, I have five observations that are the numbers 1, 2, 3, 4, and 5. If I wanted to calculate the average or the mean of a set of data, I might set up some labels just to keep my tables organized. So the average or the mean, we'll use the textbook's term, the mean, and the median. And maybe for the sake of organization, we'll put my variables across the left side, since that's how they're organized in the data. And I'll put the mean and the median across the top. So the built-in command in Excel to calculate a mean or an average, it is not mean. If you type in mean, nothing comes up. But there is a command called average. As for all Excel built-in commands, once you've typed in the command, you open a set of parentheses, and we see here Excel is looking for a bunch of numbers to take the average of. So you could either type in a bunch of numbers separated by commas, you could type in cell references separated by commas, or you could type in or select with your cursor an array or a whole block of cells. So we're going to have Excel take the average of everything between B1 and F1. Close your parentheses, and the value is 6, and I know that's correct. If you wanted to, you could also add them all up and divide by 5, which is the standard formula for calculating a mean. Now there's some shortcuts here. To calculate the mean of the variable y, we could do the same thing. You could type in equals average parentheses B2 to F2, or you can copy the formula that's in the cell B6, right click and hit copy, and then paste that into B7, and we see the values changed here. Up at the top in the command window there, you see it says calculate the average of B2 to F2, even though what I copied and pasted was a different command, average B1 to F1. The reason that happened is when I moved that formula, that copied formula, down one cell, all the references to those cells also went down by 1. So there it's taking the average of everything in row 1. And when I moved that formula down 1, now it's taking the average of everything in row 2. And there's even a faster way to do this. If you have one cell highlighted and you see that little square in the lower right corner, if you put your cursor over that until it looks a little bit different, you can grab that and then drag it down. And you see that the calculations here don't make sense, but the cell references all moved automatically. So this is now taking the average of everything in row 3. This one is in row 4. This one is in row 5. This one is in row 6, and that's what I got a value of 6 there. And we can do it one more time here. The command in Excel for median is simply median. So please calculate the middle value of all of the cells in row 1 from column B to column F. And if I'd like the median of the variable YYY, I can just drag that formula down and then double click on it real quick to check, and yes, it's taken the median of the values that I want. So those built-in commands will save you a lot of time and effort when you're working through the projects or working through practice problems. The quiz questions on our online software have links to Excel files that you can open while you're working on those questions, and then you can quickly do some of that work by just knowing those built-in commands like average and median. I think there's one coming up where you have to calculate percentiles, and the formula for that is simply percentile. There we go. It's percentile EXC. Not really important what that means, but that's the correct one to use. And we see here it's looking for an array that's a block of cells to examine, and then K, it's looking for the kth percentile. So you type in 0.5 for the 50th percentile, which is the same as the median. Type in 0.68 for the 68th percentile, and so on. Now that we've got these formulas here that are going to calculate the mean and the median automatically, we could play around up top a little bit and say change one of the values. So if that second value of XXX were to change from, say, 8 to something like 18, as soon as I hit enter, this value of the mean of XXX is going to update automatically, as is the median of XXX. Y won't change, so you won't see any change in the numbers here. Now before I hit enter on that new value of 18, predict what's going to happen. Think about the way that the mean and the median are calculated. Formula for the mean is to add up all the values and then divide by the number of them. So 2 plus 8 plus 6 plus 4 plus 10 is going to become 2 plus 18 plus 6 plus 4 plus 10, and then you'll divide those sums by 5. And now that one of these values has increased and essentially become an outlier, the sum of the 5 values is going to grow, so the sum of the 5 values divided by 5 is going to grow, and we'll see that that mean should increase. Now think about how the median is calculated and predict what's going to happen to the median of XXX now that I've changed one value. The median is calculated as the middle value. So it's the value that has an equal number of data points above it and below it. Since we have an odd number of values in our variable XXX right now, there's a middle value that has excuse me, that has 2 values above it and 2 values below it. Previously this was 2, 8, 6, 4, and 10, and the value 6 had 2 values that were below it, that would be 2 and 4, and it had 2 values above it, 8 and 10, and so the median was 6. Now that we've changed that value from 8 to 18, 6 is still the value that has 2 numbers below it, 2 and 4, and 2 values above it, 10 and 18, so 6 should remain the median. And indeed we see that that's the case. The median has increased, but the median has not. Our conclusion here is that if you were to grab one value that's above the mean and the median in a symmetric distribution where the mean and median are equal, the median is sensitive to large values and would therefore get pulled in that direction. But because of the way the median is defined and calculated, the median would be unchanged if you have an extreme value like an outlier. For that reason, if you have an extreme value, maybe 11,110, the mean is going to be pulled up dramatically. And looking at that data, I kind of see that 2,226.4 isn't a particularly good measure of the middle of that data set, because there are 4 values that are 10 or lower. For that reason, because of the existence of outliers, perhaps the median is a better measure of the center of the data, although both are really technically measures of center, but I think the median is probably a better estimate or a better measure of a typical value or sort of the middle value, although they're really just different definitions of what middle means.